This check-in is talking about, it's got this person and this person. This person throws a ball that goes right past this person's arm, and then it falls down to the ground. It's saying if the second person here threw a second ball that went with the same speed and the same angle, so that it went in that same path with the same speed and everything as this ball did, right as it passed, they throw it, so they both go like that. It's saying how long would this ball, the second ball, take compared to the first ball? What did y'all say? Yes, sir, what you got?
I just put half.
Half was right. Yeah, because, yeah, I mean, you can kind of see, like, this is half the distance as, or what, this is half the distance as this whole thing. And that's exactly right. This thing, like, if this thing fell twice, right next to each other, that would be the same as it doing this. This is basically it falling backwards, if you can think about it like that. It's going fast in the up direction, and then it slows down, and then it stops, and then it goes fast in the down direction. But like its up speed here would be exactly the same as its down speed here. This is just the same motion except backwards. So this speed, this time would be exactly the same amount as this time, which means that just the falling time would be half of this time. Another way to say that is this whole time is twice just this falling time.
Okay. Well, but what if, all right, say the first person threw it, right?
Yeah.
And the second that it got to the second person threw his ball. So the balls were like this.
Yeah,
right?
yeah.
Same speed, same whatnot. Would they still land like at like the same time?
If they threw it just right, yeah. And that's what I'm saying is happening.
Right.
So
like wind, would it have any like?
oh, no wind. There's no wind in physics unless you want to make it real complicated.
Okay.
Yeah. I mean, you can do physics with wind, but you don't want to like that. That's when we're learning it. That's too much. When you're doing engineering stuff, you got to think about the wind. You don't think about the wind, your rocket's going to crash or whatever you're doing. Flying cars, anybody? Flying cars aren't a good idea. They're going to break down and fall out of the sky and break a bunch of other things. Dang, my cup is leaking.
Hovering cars does not sound like a bad idea.
Yeah, hover cars.
Until it just.
Anyway, I mean maybe, but why not just put tires on the ground? Tires are bad though, all that rubber. Anyway, here we go. It's all on video. You're welcome. I'm going to show you how to do the lab. After you'll read the instructions for the lab, it's going to ask you to make 2 ramps. I've got some ramps here, but please see if you have your own materials. Now, I don't want y'all to use your Chromebooks, you're going to mess them up. But if you've got a binder, you can use that for one of your ramps. And if you've got something else, even if it's something that's not exactly rigid, like a spiral notebook, you could use that. You just might have to put something underneath it so it doesn't bend in the middle, you know. Anyway, you're going to have 2 ramps. One ramp just to speed the marble up, and you don't need to measure the angle of the ramp the marble rolls down. You'll need to measure the angle of the second ramp, though. So what you're going to do, this second ramp is to launch the ball, and you're measuring the angle from here to the floor, so there's this little bit of angle. It's going to help for this first ramp that it rolls down to be steeper than the other ramp, and you're going to want it to go here. That's not the way to do it. You want it to go, there we go, I did it. Hey, come back. So it's going to go like that. You don't want it to go off and then down somewhere else. You want it to land at about the same height it went to. Just like this guy, see? This guy started it from right there, and then it landed at about that same height he threw it from. You don't want it to go there and then go like way down off a cliff. That's not gonna, we're not gonna be able to analyze that as well. So, just like this guy, when the thing starts going up, it's when you start timing. So you're going to time from this point, from the bottom of the ramp it rolls up, to the moment it lands. So here we go, if I can do this again. Boom! So I'll time, here I'll say it again and I'll say start stop, for when I start timing and when I stop timing. No. Oh, this hurts my hand. I need to go home for for approximately 3 days. Here we go. Boom! Alright, I forgot to say start, stop.
Yeah, so you just say.
I got really excited with the marble. Start. There we go. So you see, it's not about where it rolls to, it's about when it lands. And start timing when it gets to this bottom part of the ramp it rolls up. That's likewise the distance you'll measure. It landed about here, so you'll measure the horizontal distance from here to here. So that distance. And then be careful to make your table right. Those are the 3 things you need to measure with this lab. The angle of the ramp it rolls up, the distance from the bottom of the ramp it rolls up to where it lands, and the time it takes to go from those 2 spots, in between those 2 spots. Deal?
No.
Questions? Okay. Please start reading those instructions for the lab and start thinking about what you're going to use for a ramp.
Were you recording yourself?